In mathematics, a sequence is a list of objects. It can be numbers, letters, names, etc. For example, 2, comma, 4, comma, 6, comma, 8. This is a list of first four even numbers. The members of a sequence are known as terms or elements of the sequence. So here the first term is 2. So I can say T1, second term T2, third term T3, fourth term T4. They are also written as A1, A2, A3, A4, and so on. A sequence can be finite or infinite. If it has countable number of terms, like in this case 2, 4, 6, and 8, so there are only 4 terms, this is a finite sequence. And if we say all natural numbers 1, 2, 3, 4, and so on, this is an infinite sequence. A series is defined if we add or subtract all the terms of a sequence. So for example, if we have 2, comma, 4, comma, 6, comma, 8, comma, 10, a finite sequence, the corresponding series will be 2 plus 4 plus 6 plus 8 plus 10. Similarly, if you have any infinite sequence, like the sequence of natural numbers, the series corresponding to that will be 1 plus 2 plus 3 plus 4 and so on. This will be an infinite series. Sequences whose terms follow a particular pattern are known as progressions. For example, 2, comma, 4, comma, 6, comma, 8, and so on. This is a progression because the difference of any two consecutive terms is 2. Similarly, if we write A plus D, A plus 2D, and so on, this is also a progression because the difference of any two successive terms will be D. Now let's look at some examples. Write down the sequence whose nth term is 2 raised to the power n divided by n. Let's call this nth term as an, where n is any natural number. By substituting n equals 1, we get a1 equals 2 raised to the power 1 divided by 1, which is 2. And n equals 2 gives you a2, which is 2 raised to the power 2 divided by 2. That is 4 over 2 or 2. When you replace n with 3, you get 2 raised to the power 3 divided by 3. And that is 8 over 3. Replacing n with 4, you get 2 raised to the power 4 divided by 4. That is 16 divided by 4 or 4. In same way, we can find all the terms. So the sequence will be 2, comma, 2, comma, 8 over 3, comma, 4, and so on. Let's find the sequence of numbers defined by an, where an is equal to 1 over n when n is odd and it is negative 1 over n when n is even. So when n is odd, n can take values like 1, 3, 5, and so on. So we'll have a1 equals 1 over 1. a3 will be equal to 1 over 3. a5 will be equal to 1 over 5. Similarly, when n is even, so it can take values like 2, 4, 6, and so on. So you have a2 equals 1, negative 1 over 2. a4 equals negative 1 over 4. a6 equals negative 1 over 6, and so on. So the sequence will be 1, negative 1 over 2, 1 over 3, negative 1 over 4, 1 over 5, negative 1 over 6, and so on. The Fibonacci sequence The Fibonacci sequence is defined by A1 and A2 equals 1, and AN is equal to AN minus 1 plus AN minus 2, where N is greater than 2. We need to find the value of AN plus 1 over AN for N equals 5. So here we are given with A1 equals 1, A2 is equal to 1, A3 will be equal to A3 minus 1, which is 2, plus A3 minus 2, which is 1. So we have 1 plus 1 equals 2. Similarly, A4 will be equal to the sum of previous two terms, which is A3 and A2. So A3 was 2, A2 was 1, so that is 3. Similarly, A5 is sum of previous two terms, which is A4 and A3. A4 was 3 and A3 was 2. So that is equal to 5. Similarly, we can find A6, which is A5 plus A4. A5 was 5 and A4 was 3. So that is 8. And we want to find AN plus 1 over AN for N equals 5. That means we want to find out A6 over A5. A6 is 8 and A5 is 5. So the answer is 8 over 5. Arithmetic progression is a sequence whose terms increase or decrease by a fixed number, and the fixed number is called the common difference. For example, 2, 4, 6, 8, and so on. In this sequence, the terms increase by number 2. Similarly, 8, 6, 4, 2, 0, and so on. This is also an AP or arithmetic progression because the numbers decrease by 2. If A is the first term and D is the common difference, an AP can be written as A plus D, A plus 2D, A plus 3D, and so on. The nth term can be written as A plus n minus 1D. Here we can write the nth term formula, which is A plus n minus 1D, which is also the last term in a finite sequence. So it is also denoted as L. Show that the sequence 9, 12, 15, 18, and so on is an AP, and find its 8th term and the general term. General term is nothing but the nth term. Here, the first term is 9, so we can call A equals 9. Let's recall the definition of an AP. Any sequence which increases or decreases by a fixed number is called an AP. If you observe here, we see that the first term is 9, the second term is 12, the third term is 15, the fourth term is 18. The difference of second term and first term is 3. The difference of the third term and the second term is also 3. The difference of fourth term and the third term is also 3. So here the terms increase by a fixed number, which is 3. Therefore, this is an AP. So we have the first term A equals 9. The common difference is 3. We need to find the 8th term. We know that the general term or nth term formula is AN equals A plus n minus 1D. The general term is 9 plus n minus 1 times D, which is 3, which can be simplified to 9 plus 3n minus 3 or 6 plus 3n. So the general term is 6 plus 3n, and we want to find the 8th term. So you replace n with 8. So replacing n with 8, we get 6 plus 3 times 8, which is 6 plus 24 or equals 30. We can also find 8th term directly by using the formula A8 equals A plus 8 minus 1D or A plus 7D. And this will be 9 plus 7 times 3. So you have 9 plus 21, which is equal to 30. Show that the given sequence is an AP and find its nth term. Here, the given sequence is log A, comma, log AB, comma, log AB squared, comma, log AB cube, and so on. Let's recall the definition of an AP. A sequence is called an AP if it increases or decreases by a fixed number. In order to prove that this sequence is an AP, we will find the difference of second term and the first term, the third term and the second term, the fourth term and the third term. Second term minus the first term gives us log AB minus log A. And by using the log properties, we know that log A minus log B is same as log A over B. So it will be log AB over A, which gives you log B. Similarly, subtracting the third term and the second term, we get log AB square over AB, and which is same as log B. Similarly, we can find log AB cube minus log AB square equals log AB cube over AB square, which is same as log B. As the difference between any two successive terms is the same, therefore the sequence is an AP. Now we need to find the nth term of this sequence. The formula for nth term of the sequence is given as A plus n minus 1 D. Here A is equal to log A, n minus 1, and D is equal to log B. And the second term here can be simplified by using the formula m log n is same as log n raised to the power m. So we have an equals log A plus log B raised to the power n minus 1, which is same as log m plus log n, which is log mn. So nth term can be written as log A B raised to the power n minus 1. In a certain AP, 5 times the fifth term is equal to 8 times the eighth term. Find the 13th term. We are given with 5 times the fifth term. So 5 times A5 is equal to 8 times A8. We know that the formula for nth term is A plus n minus 1D. Fifth term can be written as A plus 5 minus 1, which is 4. So 4D. Similarly, eighth term can be written as A plus 7D. And if we simplify this equation, we get 5A plus 20D equals 8A plus 56D. Isolating all the terms on one side, we get 8A minus 5A plus 56D minus 20D equals 0, which simplifies to 3A plus 36D equals 0. Here we see that 3 is a common factor among 3A and 36D. So we can divide throughout by 3. So we will get A plus 12D equals 0. And what we wanted to find? We wanted to find the 13th term. What will be the formula for 13th term? It will be A plus 12D, and which we got equals 0. Therefore, the 13th term is equal to 0. Find the term of the series given below, which is numerically the smallest. The given sequence is 25, 22, 3 over 4, 20, 1 over 2, 18, 1 over 4, and so on. We can easily prove that this sequence is an AP with the first term equals 25 and the common difference which can be found by subtracting the second term and the first term. So we have 22 3 over 4 minus 25. 22 3 over 4 is same as 91 over 4 minus 25, which can also be written as 100 over 4, right? So we have the common difference as negative 9 over 4. So we have the first term, we have the common difference. We want to find the term which is numerically the smallest term. That means we want to find the term which has smallest positive value. And after that, the terms will become negative. In order to find that, what we can do is we can set up the nth term less than 0. So if we are able to find out which is the first negative term, the term before that will be the numerically smallest term. Let's set up Tn less than 0. The nth term formula, which is a plus n minus 1d, that should be less than 0. We have a equals 25 plus n minus 1 and d is equal to negative 9 over 4. That is less than 0. And if we simplify this further, we get 25 minus 9 over 4n, and negative 1 times negative 9 over 4 is plus 9 over 4, that is less than 0. Multiplying throughout by 4, we get 100 minus 9n plus 9 less than 0, which simplifies to 109 minus 9n less than 0, or 109 less than 9n, or 109 over 9 is less than n. That means n is greater than 109 over 9, which is same as 12 1 over 9. For n greater than 12 1 over 9, that means for n equals 13, we will have the first negative term. So let's find the 13th term. That will be d13 equals a plus 12d. A is 25 plus 12 times d is 9 over 4. So you cancel out 12 and 4. So you have 25 minus 27. So that is negative 2. So this is how we find the first negative term. But our motive is to find the numerically smallest term. In order to find the numerically smallest term, we'll go one step back. So for n equals 12, we find T12. So T12 will be equal to A plus 11D. So that is 25 plus 11 times negative 9 over 4. And if we simplify this, we will get 1 over 4. That is the numerically smallest term. So in this question, we have learned two things. One, how to find the first negative term in a decreasing sequence. Two, how to find the numerically smallest term in an AP. Consider the following two APs, 2, 7, 12, 17, and so on up to 500 terms. 1, 8, 15, 22, and so on, 300 terms. We need to find the number of common terms and the last common term. In the first AP, the first term is 2. The common difference is 7 minus 2, which is 5. There are 500 terms, so the last term, T500, will be equal to A plus 499D. So 499 times D, which is 5. And this is equal to 2497. Similarly, in the second AP, A is 1, D is 8 minus 1, which is 7. The last term, T300, will be equal to 1 plus 299 times 7. And this gives us 2094. So we have the last term of first AP, we have the last term of second AP. We know the common difference of these two APs. Whenever you are asked to find the common terms among two APs, we find the first common term. So here the first common term is 22. We find their common difference. So common difference of first AP is 5. The common difference of second AP is 7. And to find the common difference of the new AP that we are looking for, the common terms AP, we take the LCM of these two common differences. So for the new AP that we are looking for, first term is 22, the first common term, and the common difference is LCM of 5 and 7. So LCM of 5 and 7 is 35. So we know the first term, we know the common difference, we can write the sequence. So the common terms sequence will be 22, 57, 92, and so on. In order to find the number of terms in this sequence, we can use the last term of the two given sequences. The last term of the first sequence was 2497, and the last term of the second sequence was 2094. The smallest number among these two is 2094. That means the nth term of this new sequence should be less than or equal to 2094. That means A, which is 22, plus n minus 1 times D, which was 35, should be less than or equal to 2094. Let's subtract 22 on both sides. So we have n minus 1 times 35 is less than equal to 2072, or n is less than equal to 2072 over 35 plus 1, which simplifies to less than equal to 60.2. The nearest integer here is 60. That means there are 60 common terms. And in order to find the last common term, now we know that the last common term will be the 60th term. So we need to find T60 for the new AP. A, which is 22, plus 59D, D is 35. And this gives us 2087. If A1, A2, A3, and so on up to AN are in AP, where AI is greater than 0 for all I, then show that 1 over square root A1 plus square root A2 plus 1 over square root A2 plus square root A3, and so on up to 1 over square root AN minus 1 plus square root AN is equal to n minus 1 over square root A1 plus square root AN. From an AP, the first thing that comes to mind is the common difference. So here the common difference will be equal to either A2 minus A1 or A3 minus A2 or A4 minus A3 or so on. We can say AN minus 1, right? So D is equal to all of them. Now let's think how we can use this information in this given equation. On the left hand side here, we see that we have A1, A2 in the first term. In the second term, we have A2 and A3. And similarly, in the last term, we have an minus 1 and an, but they are under the square roots and they are not in the form of a2 minus a1 or a1 minus a2 and so on. To get rid of the square root from the denominator, we can rationalize each term. And before we rationalize, we can rewrite all the terms. So the first term here, which is 1 over square root a1 plus square root a2, can also be written as 1 over square root a2 plus square root a1. And now if we rationalize with square root a2 minus square root a1. So rationalizing the first term will give us square root a2 minus square root a1 over, and the denominator is in the form of a plus b times a minus b, which is a square minus b square. So we'll have square root a2 square minus square root a1 square. So you have square root a2 minus square root a1 over a2 minus a1. So the first term, which was 1 over square root a2 plus square root a1, is now in the form of square root a2 minus square root a1 over a2 minus a1, which is equal to d. Similarly, we can prove that the second term will be 1 over square root a3 plus square root a2 equals square root a3 minus square root a2 over d. And same way we can find all the terms, and the last term, which is 1 over square root an plus square root an minus 1, will be equal to square root an minus square root an minus 1 over d. Adding all these terms will give us the left hand side. So the left hand side now is equal to d is common denominator, so we can write 1 over d out. The first term, which was square root a2 minus square root a1, plus the second term, which was square root a3 minus square root a2, plus, and so on. And the last term, which is square root an minus square root an minus 1. Here we will observe that starting from a2, all the terms will cancel out except square root a1 and square root an. So square root a2 positive and negative will cancel out. And similarly, there will be a negative square root a3, which will cancel out with a positive one. And same way, we'll have square root an minus 1 and negative square root an minus 1, which will cancel out. So eventually, we'll be left with 1 over d times square root an minus square root a1. And here we can rationalize this and write it as 1 over d times an minus a1 over square root an plus square root a1. 1 over d times, we know that an is the first term, a1 plus n minus 1d, and a1 is a1, so negative a1, divided by square root an plus square root a1. You can cancel out a1, and after that we can cancel out d. So we are left with n minus 1 over square root an plus square root a1, which is equal to the right hand side. Some important properties of terms of an AP. For any A, B, and C in AP, 2B is equal to A plus C. And this comes from the fact that the common difference is same throughout. So B minus A should be equal to C minus B, simplifying which we get B plus B equals A plus C, or 2B is equal to A plus C. Adding or subtracting a number to or from an AP results in an AP. For example, if you have an AP 2, 4, 6, 8, 10, and so on. If you add 1 to each term, we'll get 3, 5, 7, 9, 11, and so on. This is still an AP because the common difference is the same. Same thing applies for subtraction. If you multiply or divide each term of an AP by a fixed number, we get a new AP. For example, in the sequence 2, 4, 6, 8, and so on, if you divide all the terms by 2, we will get 1, 2, 3, and so on, which is an AP. Whenever we need to consider three successive terms of an AP, we should preferably take them as A minus D, A, and A plus D. Similarly, for four terms, we should consider them as A minus 3D, A minus D, A plus D, and A plus 3D. The reason being it helps in easier calculations. If B plus C minus A over A, C plus A minus B over B, A plus B minus C over C are in AP, then prove that 1 over A, 1 over B, and 1 over C are also in AP. We are given with B plus C minus A over A, C plus A minus B over B, and A plus B minus C over C. They are in AP. We know that if we add, subtract, multiply, or divide a fixed number to these, the resulting sequence will also be an AP. If I add 2 to each term here, and if we take LCM, we get B plus C minus A plus 2A, which gives us plus A over A. Similarly, the second term will change to C plus A plus B over B. And the third term will change to A plus B plus C over C. Here we observe that the numerator of all these terms is A plus B plus C. So if we divide throughout by A plus B plus C, the resultant sequence will also be an AP. So dividing by A plus B plus C throughout, we get 1 over A, 1 over B, 1 over B, and 1 over C are in AP. If the sum of three numbers in AP is 24 and their product is 440, find the numbers. Whenever we need to assume three numbers in AP, we assume them as A minus D, A, and A plus D. It is given that their sum is 24. If you add these three, D will cancel out, so we'll have 3A that is given equals to 24. And from here, dividing both sides by 3, we get A equals 8. And it is given that their product is 440. That means A minus D times A times A plus D is equal to 440. Here, A minus D times A plus D will give you A square minus D square. So you have A square minus D square times A is equal to 440. We know the value of A, so we can substitute it here. So you have 8 square minus D square times 8 is equal to 440. Dividing both sides by 8, we get 64 minus D square equals 55. And from here, we get D square equals 9, or D equals plus or minus 3. So you have the value of D, we have the value of A, we can find the numbers. So A is equal to 8, D is equal to 3, or D is equal to negative 3. So when D is equal to 3 and A is equal to 8, the numbers which are A minus D, A, and A plus D will be 8 minus 3, 8, and 8 plus 3. So they are 5, 8, and 11. For D equals negative 3, the numbers would be 8 minus negative 3, 8, 8 plus negative 3. So they are 11, 8, and 5. Arithmetic mean, or AM, between any two numbers is given by their average. If we have three terms, A, capital A, and B in AP, then their arithmetic mean is given as A equals A plus B over 2. In general, if you have two numbers A and B, and in between these two numbers, if we insert n terms, A1, A2, A3, and so on up to AN, such that the resulting sequence is an AP, then A1, A2, A3, and so on up to AN are known as the arithmetic means between A and B. And converse is also true. So if we are given with a sequence A, comma, A1, comma, A2, and so on up to B, and A1, A2, A3, and so on up to AN are AMs, then the sequence will be an AP. For example, 2, 4, 6, 8, 10, 12. This sequence is an AP. Therefore, 4, 6, 8, and 10 are AMs between 2 and 12. And we can say the opposite as well, because 4, 6, 8, and 10 are AMs. Therefore, this whole sequence is an AP. Going back to inserting n arithmetic means between A and B. So we have A arithmetic mean 1, which is A1, then A2, A3, and so on up to AN, and the last term, which is B. Now here we see that there were two terms A and B, and then we inserted n terms in between them. That means in total we have n plus 2 terms, right? So B is n plus second term, right? So we have B equals A n plus 2, the n plus second term. So the formula for that will be A plus n plus 2 minus 1D, right? And from here we get B equals A plus n plus 1D, or we can also say B minus A over n plus 1 is equal to D. This will help us to find all the terms A1, A2, A3, and so on if required. So we know D, and A1 is placed at second number. That means it's a second term, right? So it will be equal to A plus D. That means A plus B minus A over n plus 1. Similarly, A2 will be equal to A plus 2D. So A plus 2 times B minus A over n plus 1. Same way we can find all the arithmetic means. Between 1 and 31, m arithmetic means are inserted such that the ratio of 7th and m minus 1th means is 5:9. Find the value of m. Whenever you have a question about arithmetic means, we use the formula d equals b minus a over n plus 1 to find out the value of d. Here we are given with the numbers a, which is 1, and b, which is 31, and m arithmetic means are inserted. So n is equal to m. So d will be equal to b minus a. So that is 31 minus 1. So 30 over n plus 1. So m plus 1. So we have the value of d. We know the value of a. And we are given with the condition that 7th mean to m minus 1th mean, their ratio is 5:9. So we have two numbers 1 and 31, and there are m means between them. So first mean is A1, second mean is A2, and so on up to AM. So here A1 is the second term, so it will be equal to A plus D. A2 will be equal to A plus 2D. Similarly, A7 will be equal to A plus 7D. We know A, which is 1, 7 times. We know D, which is 30 over M plus 1. If we simplify this, we get M plus 1 plus 210 over m plus 1, and that gives you m plus 211 over m plus 1. Similarly, am minus 1 will be equal to a, which is 1, plus m minus 1 times d. D is 30 over m plus 1. And if we simplify this, we get m plus 1 plus 30m minus 30 over m plus 1. Simplifying this further, we get 31m minus 29 over m plus 1. So we have the 7th mean and m minus 1th mean. We are given with the ratio as 5 over 9. So let's substitute the values. A7, which is m plus 211 over m plus 1, divided by 31m minus 29 over m plus 1, that is equal to 5 over 9. We can cancel out m plus 1. And if we cross multiply the remaining terms, we get 9m plus 1899 is equal to 155m minus 145, and which gives us 146m is equal to 2044, simplifying which we get m equals 14. Find the value of n if am between a and b is a raised to the power n plus b raised to the power n divided by a raised to the power n minus 1 plus b raised to the power n minus 1. We know that arithmetic mean between a and b is given as a plus b over 2, but here it is given equals to a raised to the power n plus b raised to the power n divided by a raised to the power n minus 1 plus b raised to the power n minus 1. So this is the initial equation that we can set up, and we simplify this to get the value of n. Cross multiplying, we get a raised to the power n minus 1 plus b raised to the power n minus 1 times a plus b is equal to 2 times a raised to the power n plus 2 times b raised to the power n. On the left hand side, if we simplify, we get a raised to the power n plus b raised to the power n plus a raised to the power n minus 1 times b plus b raised to the power n minus 1 times a is equal to 2a raised to the power n plus 2b raised to the power n. We can cancel out 1 a raised to the power n and b raised to the power n by subtracting it on both sides. So we are left with a raised to the power n minus 1 times b plus b raised to the power n minus 1 times a is equal to a raised to the power n plus b raised to the power n. Rearranging the terms, we get b raised to the power n minus 1 times a minus b raised to the power n is equal to a raised to the power n minus a raised to the power n minus 1 times b. On the left hand side, if we take b raised to the power n minus 1 common, we will be left with a minus b. Similarly, on the right hand side, if we take a raised to the power n minus 1 common, we have a minus b. Dividing throughout by a minus b will cancel out, so we're left with b raised to the power n minus 1 is equal to a raised to the power n minus 1, which gives us a over b raised to the power n minus 1 equals to 1, which can also be written as b over a raised to the power n minus 1, however you want to write it. In order to find n, we can write the right hand side as a over b raised to the power 0. Now, these two terms, the bases are the same, so the powers should be equal. That means n minus 1 should be equal to 0, or n should be equal to 1. Sum of terms of an AP. If you have an AP 2, 4, 6, 8, 10, 12, if you observe carefully, we see that the sum of first and the last term is 14. The sum of second and second last term is also 14. Sum of third and third last term is also 14, right? So we have three groups of 14. And that will give you the sum of this AP, right? Or we can also write it as that there were 6 terms divided by 2, add the first term and the last term. And that should give you the sum of all the terms of this AP. And this works for all the APs. So in general, I can say n over 2, the number of terms divided by 2, the first term plus the last term of the AP gives you the sum of n terms of that AP. Let's consider the AP as A plus D, A plus 2D, A plus 3D, and so on. And the last term as L. So the second last term will be D less than that. So L minus D. The third term will be D less than that. So L minus 2D and so on, right? So sum of these terms, if I write it as Sn, that will be equal to A plus D plus A plus 2D and so on up to L. If we reverse this series, so we get Sn is equal to L plus L minus D plus L minus 2D plus and so on up to A. If we add these two equations, we get 2 times Sn is equal to A plus L. Adding the second terms here, D will cancel out, so you get A plus L. Similarly, adding the third terms, 2D will cancel out, so you have A plus L, and so on up to the last one is also A plus L. So you have n groups of A plus L. That means 2 times Sn is equal to n times A plus L. And from here we write Sn is equal to n over 2 times A plus L, where L is the last term here. And if we use the formula for L, we'll get Sn is equal to n over 2 times A plus L, which is A plus n minus 1 times D. That means Sn is equal to n over 2 times 2A plus n minus 1 times D. Find the number of terms in the series 20, 19 1 over 3, 18 2 over 3, and so on, the sum of which is 300. Explain the double answer. Here we have A equals 20, D is equal to 19 1 over 3, which is 58 over 3, minus the first term, which is 20. So you get negative 2 over 3. So we have the value of A, we have the value of D, we don't know the number of terms, but we know the sum of this series. We know the formula Sn equals n over 2, 2A plus n minus 1 times D. Sum is given as 300, so 300 is equal to n over 2 times 2A, A is 20, so 2 times A is 40 plus n minus 1 times the value of D, which is negative 2 over 3. Dividing by 2 on the right hand side, we get 300 is equal to n times 20 minus n minus 1 over 3. Taking LCM on the right hand side, we get 300 equals n times 60 minus n plus 1 over 3. And if we multiply both sides by 3, we get 900 is equal to, and this 3 will cancel out. So you have 61n minus n squared. So we get a quadratic equation as n squared minus 61n plus 900 is equal to 0. Factorizing this, we get n minus 25 times n minus 36 equals 0. So we have two values of n as 25 or 36. We got two values of n equals 25 and 36. As we know that sum of 25 terms is 300, so let's find 26th term, which is A plus 25D. And if we find it by using the values of A and B, we'll get it as 10 over 3. The next term will be 8 over 3. Similarly, the next term will be 6 over 3, 4 over 3, 2 over 3, and 31st term will be 0. The next term will be negative, so it will be negative 2 over 3, negative 4 over 3, negative 6 over 3, negative 8 over 3, negative 10 over 3. So that is 32nd, 3rd, 4th, 5th, and 36th term. So here we find out that the sum of these terms will be 0. Therefore, the sum of 25 terms and sum of 36 terms is same. And this explains the double answer of value of n. Find the sum of first 24 terms of an AP if it is known that A1 plus A5 plus A10 plus A15 plus A20 plus A24 is equal to 225, where A1, A2, A3, and so on, these are the terms of this AP. So we are known with one fact that in any AP, the sum of first term and the last term, the sum of second term and the second last term, sum of third term and the third last term, and so on, they are equal. Similarly, in this case, as we want to find the sum of 24 terms, that means the first term and the 24th term, their sum will be same as the 5th term and the 20th term, which will be same as the 10th term and the 15th term, right? So using this fact in the given equation, which is A1 plus A5 plus A10, if we regroup that, we get A1 plus A24, A5 plus A20, plus A10 plus A15. And this is given equals to 225. All of them are equal, so we can consider any one of them. So we have three groups of A1 plus A24. And that is equal to 225. So from here, we can find the value of A1 plus A24, which will be 225 over 3. And how do you find the sum of 24 terms? That is 24 over 2, first term plus the last term. So that's 24 over 2 times 225 over 3. Simplifying this, we get 75 times 12, which is 900. So sum of 24 terms of this AP is 900. If the sequence A1, A2, A3, AN, and so on is an AP, then prove that A1 square minus A2 square plus A3 square minus A4 square plus so on up to A2n minus 1 square minus A2n square is equal to n over 2n minus 1 times A1 square minus A2n square. Let's start with the left-hand side here. The left-hand side here is given as A1 square minus A2 square plus A3 square minus A4 square. So if we group the terms like this, similarly at the end we have A2n minus 1 square minus A2n square. So all these groups are in the form of A square minus B square, which is equal to A plus B times A minus B, correct? So we have A1 minus A2 times A1 plus A2. Similarly, we have A3 minus A4 and A3 plus A4, and so on. The last term, which is A2n minus 1 minus A2n times A 2n minus 1 plus a2n. You know that a1 minus a2, a3 minus a4, and a2n minus 1 minus a2n are nothing but the common difference, but the negative common difference, because we know that d is equal to a2 minus a1, right? So minus d will be equal to a1 minus a2. Similarly, a3 minus a4 is also the value of negative d. So in all these terms, we have something common, which is negative d. So we take negative d common, and what we're left with? We're left with a1 plus a2 plus a3 plus a4, and so on up to a2n minus 1 plus a2n. This is nothing but the sum of an AP from a1 to a2n. So there are 2n terms in this sequence. So we have negative d. The formula for sum of all the terms of an AP is the number of terms, which is 2n here, divided by 2 times the first term plus the last term. So first term plus the last term. So we can cancel out 2. So we have negative nd times a1 plus a2n. What we want to prove on the right hand side, we have a1 squared minus a2n squared. So in order to get that, what we can do is we can multiply and divide by a1 minus a2n. So if we multiply and divide by this, the numerator will become a plus b times a minus b form. So it will be a square minus b square. So we have negative nd times a1 squared minus a2n squared divided by a1 minus a2n. And now we can replace a2n with the general term formula. So negative nd a1 squared minus a2n squared divided by a1 minus a1 plus 2n minus 1 times d. And if we simplify this, we get negative nd a1 squared minus a2n squared divided by negative 2n minus 1 times d. a1 will cancel out. So we can cancel out the negative sign. We can cancel out d. And we are left with n divided by 2n minus 1 times a1 squared minus a2n squared, which is same as the right hand side. In an AP, the common difference is non-zero, and the sum of first 3n terms is equal to the sum of next n terms. Then find the ratio of sum of first 2n terms to the next 2n terms. So here we are given with that d is not equal to 0, one thing. Second, the sum of first 3n terms, which can be written as sum of 3n terms, S3n, that is equal to sum of next n terms. So here we are talking about that there were 3n terms and then next n terms. So in total, we are talking about 4n terms, right? So the sum of next n terms can also be written as the sum of all these 4n terms minus the sum of 3n terms, right? So this will be sum of 4n terms minus sum of 3n terms. And simplifying which you get 2 times sum of 3n terms is equal to sum of 4n terms. We can apply the formula for 3n terms and 4n terms. So it will be 2 times sum of 3n terms will be 3n divided by 2 times 2a plus 3n minus 1 times d, and that is equal to 4n over 2 2a plus 4n minus 1 times d. Here we can cancel out 2 on both sides and n on both sides. Multiplying rest of the terms, we get 12a plus 18n minus 6 times d is equal to 8a plus 16n minus 4d. Isolating a terms on one side and d terms on one side, we'll get 12a minus 8a is equal to 16n minus 4 minus 18n plus 6 times d. If we simplify that further, we'll get 4a is equal to negative 2n plus 2 times d. And we can divide throughout by 2. So we have 2a is equal to negative n plus 1 times d. Now we want to find out the ratio of sum of first 2n terms to the next 2n terms. So 2n terms and next 2n terms, that means in total you have 4n terms, right? And in order to get the sum of the last 2n terms, what you can do is take the sum of all the terms and subtract the sum of first 2n terms. Therefore, we can write the ratio of S2n and S4n minus S2n. So this is what we want to find out. We can apply the formula for S2n, which is 2n over 2 times 2a plus 2n minus 1 times d. Similarly, in the denominator, we can apply the formula, which will be 4n over 2, 2a plus 4n minus 1 times d minus 2n over 2 times 2a plus 2n minus 1 times d. We can take out 1 over 2 common in the numerator and denominator and cancel out. We can take out n common from the numerator and denominator and cancel out. And we can also take 2 common in the numerator and denominator and cancel out. So we are left with 2a plus 2n minus 1 times d divided by 2 times 2a plus 4n minus 1 times d minus 2a plus 2n minus 1 times d. And we already found the value of 2a. If we substitute that value of 2a here, it was 1 minus n times d. So the equation changes to 1 minus n times d plus 2n minus 1 times d divided by 2 times 1 minus n times d plus 4n minus 1 times d minus 1 minus n times d plus 2n minus 1 times d. We can take out d common from the numerator and the denominator and cancel out. So we are left with 1 minus n plus 2n minus 1 divided by 2 times 1 minus n plus 4n minus 1 minus 1 minus n plus 2n minus 1, which can further be simplified to n divided by, and simplifying the denominator, we'll get 5n, and we can cancel out n, so the ratio is 1:5. The sum of n terms of two APs are in the ratio 5n plus 4 is to 9n plus 6. Then find the ratio of their 18th terms. So here we are given with sum of n terms of one AP divided by sum of n terms of another AP is equal to 5n plus 4 divided by 9n plus 6. Let's consider that for first AP, the first term is A and the common difference is D. For second AP, the first term is A, the capital A, and the common difference is capital D. So the sum of n terms for the first one will be written as n over 2 times the first term plus n minus 1 times d, and this is divided by n over 2a plus n minus 1 times d, and that is equal to 5n plus 4 over 9n plus 6. We can cancel out n over 2 on the left hand side. So we are left with 2a plus n minus 1 times d over 2a plus n minus 1 times d is equal to 5n plus 4 over 9n plus 6. Here, if we divide the numerator and denominator on the left-hand side by 2, we will get a plus n minus 1 over 2 times d, and the denominator will be a plus n minus 1 over 2 times d, that is equal to 5n plus 4 over 9n plus 6. We got it by dividing the numerator and denominator by 2. Comparing the numerator with 18th term formula for first AP, it should be a plus 17d, and we have a plus n minus 1 over 2d. That means n minus 1 over 2 should be equal to 17. And from here we get n minus 1 over 2 is equal to 17, or n is equal to 35. So if we substitute n equals 35, we get a plus 35 minus 1 over 2 times d, a plus 35 minus 1 over 2 times d is equal to 5 into 35 plus 4, 9 into 35 plus 6. And on the left hand side, you get the ratio of 18th terms. So 18th term of the first AP and 18th term of the second AP is equal to 179 divided by 321. The ratio of sums of m and n terms of an AP is m square is to n square. Show that the ratio of mth term to the nth term is 2m minus 1 over 2n minus 1. The sum of m terms of an AP can be written as m over 2 times 2a plus m minus 1 times d. Sum of n terms of the same AP can be written as n over 2 2a plus n minus 1 times d. And we are given with the ratio of these two. So Sm divided by Sn is given as m square over n square. If we substitute the values of Sm and Sn, we can cancel out 2. So we have m over n times 2a plus m minus 1 times d divided by 2a plus n minus 1 times d is equal to m square over n square, and we can cancel out 1m and n as well. Now we are left with 2a plus m minus 1 times d divided by 2a plus n minus 1 times d, and that is equal to m is to n, or m over n. Here, if we replace m by 2m minus 1 and n by 2n minus 1, the above relation will change to 2a plus 2m minus 1 minus 1 d divided by 2a plus, in place of n we are writing 2n minus 1, and this negative 1, so negative 1 times d is equal to, replace m with 2m minus 1 divided by n with 2n minus 1. And now if we simplify the left hand side here, we get 2a plus 2m minus 2 times d divided by 2a plus 2n minus 2 times d is equal to 2m minus 1 over 2n minus 1. On the left-hand side, in the numerator and denominator, we have 2 common. We can take out 2 and cancel it out. So we will be left with a plus m minus 1 times d divided by a plus n minus 1 times d is equal to 2m minus 1 over 2n minus 1. Now, a plus m minus 1 times d. This represents the mth term of this AP. Similarly, a plus n minus 1d represents the nth term of this AP. And this is what we wanted to find, right? The ratio of nth term to nth term. And that is equal to 2m minus 1 over 2n minus 1. A progression in which the first term is not equal to 0. So a is not equal to 0. And each term after the first term is found by multiplying the previous term with a constant number. And that number is called the common ratio. So the first term is a, the second term is a multiplied by a constant number. Let's call it as r. The third term is found by multiplying the second term with r, so ar squared. And the fourth term is found by multiplying the third term with r, so ar cubed, and so on. Similarly, the nth term will be ar raised to the power n minus 1. We have a as the first term, which should not be equal to 0. R is the common ratio. And the last term is given as a r raised to the power n minus 1. And to find the common ratio, we use the formula a2 over a1 or a3 over a2 or a4 over a3 and so on. An example of a GP is 1, 3, 9, 27, and so on. This sequence is a GP because here the first term a equals 1, which is not equal to 0. If we find the ratio of second term and the first term, which will be 3 over 1, is equal to 3. So that is a2 over a1. Similarly, if you find a3 over a2, that is 9 over 3, again 3. If you find a4 over a3, which is 27 over 9, again that is equal to 3. As the ratio of any two successive terms is equal, therefore this sequence is a GP. And in order to find the nth term of this sequence, we can use the formula a times r raised to the power n minus 1. A is 1 times r, which is 3, raised to the power n minus 1. So 3 raised to power n minus 1 gives us the last term or general term of this sequence. If the first term of a GP is 1 and the sum of third and fifth term is 90, find the common ratio of the GP. Here we are given with a equals 1 and we want to find the value of r. And it is also given that the sum of third and fifth term is 90. We know the formula that nth term of a GP is given as a r raised to the power n minus 1. Therefore, the third term will be equal to a r raised to the power 3 minus 1, which is 2. Similarly, a5 will be equal to a r raised to the power 4. And it is given that the sum of these two, a r squared plus a r raised to the power 4, is equal to 90. We know the value of a, which is 1, so we can substitute a as 1. So we'll have r squared plus r raised to the power 4 is equal to 90, which can also be written as r to the power 4 plus r squared minus 90 equals 0. This is a biquadratic equation. In this equation, if we assume r squared equals x, that means r to the power 4 will be equal to x squared. So this equation can also be written as x squared plus x minus 90 equals 0. Now this is a quadratic equation which we can factorize. So factorizing x squared plus x minus 90 equals 0, we get x squared plus 10x minus 9x minus 90 equals 0, which will give us two factors, x plus 10 and x minus 9. From here, we'll get two values of x. When you equate x plus 10 equals 0, you get x as negative 10. Or when you compare x minus 9 equals 0, you get x equals 9. And x was equal to r square. That means r square is equal to negative 10 or r square is equal to 9. Now, square of any number cannot be negative. So that means this value is rejected. So we have r square equals 9, which gives us two values of r as plus or minus 3. In this question, we are given with 4th, 7th, and last term of GPR 1080 and 2560. We need to find the first term and number of terms in this GP. So we are given with A4 equals 10. That means a r to the power 3 is equal to 10. A7 is given as 80. That means a r to the power 6 is equal to 80. And the last term, which is an, is given as 2560. So we have a r to the power n minus 1 is equal to 2560. We can name these equations as 1, 2, and 3. And we want to find the value of a as well as the value of n. If you divide equation 1 and 2, a will cancel out and you will have something entirely in terms of r. So we can find r from there. So let's divide equation 2 by equation 1, which will give us a r to the power 6 divided by a r to the power 3 is equal to 80 over 10. And here we can cancel out a, we can cancel out r cube. So you have r cube equals 8. R cube equals 8 means r should be equal to 2. So now we know the value of r is equal to 2. If we use this value of r in equation 1 or equation 2, we will get the value of a. If we use r equals 2 in equation 1, we get a times 2 cube is equal to 10. That means a is equal to 10 over 8 or 5 over 4. So we get the value of a as 5 over 4. Now we need to find the value of n. We know the value of a is 5 over 4. We know the value of r is equal to 2. We can substitute these two values in equation 3. So using a equals 5 over 4 and r equals 2 in equation 3, we have 5 over 4 times r, which is 2 raised to the power n minus 1 is equal to 2560. We can simplify this further by 2 raised to the power n minus 1 is equal to 2560 times 4 over 5. So you're dividing both sides by 5 over 4. The left-hand side is 2 raised to the power n minus 1. And on the right-hand side, we can cancel out 5 and 2560, which will give you 512. And if we factorize the right-hand side, we will get the right-hand side equals 2 raised to the power 11. Now here the bases are equal, therefore the powers should be equal. That means n minus 1 should be equal to 11 or n is equal to 12. And that gives you the number of terms in the sequence is 12. Is there a GP containing 27, 8, and 12 as 3 of its terms? It can be any 3 terms. If yes, how many such GPs exist? Let us assume that the first term of GP is 8 and some mth term is 12. So a times r to the power m minus 1 will be equal to 12. From here, I can say r to the power m minus 1 is equal to 12 over a, which is 8. And that gives you 3 over 2. Similarly, if we assume that nth term is 27, from here we'll get the value of r to the power n minus 1, which is 27 over 8. That can be written as 3 over 2 raised to the power 3. Here we know that 3 over 2 is equal to r raised to the power m minus 1. So we can replace 3 over 2 here with r to the power m minus 1. So we get r to the power n minus 1 is equal to r to the power m minus 1 cube, which can also be written as r to the power 3m minus 3. Now here the bases are the same, so the powers will equate. So you have n minus 1 is equal to 3m minus 3, simplifying which we get the value as n plus 2 is equal to 3m, or n plus 2 over 3 is equal to m over 1, and we can assume this equal to some integer k. So from here we can say m is equal to k and n is equal to 3k minus 2. By giving different values of k, we will get integer values of m and n. That means 27 and 12 are terms of GP if 8 is one of the terms. As k can take any value, there will be infinite number of GPs possible. Properties of terms of a GP. For any three terms A, B, and C in GP, as you know, the common ratio is same. So second term divided by the first one and third term divided by the second term should be equal. So B over A is equal to C over B, which gives us B square equals AC, or B equals square root AC. Here B is also known as the geometric mean of A and C. If you multiply or divide each term of a GP with a non-zero number, then we get a new GP. Similarly, if you raise each term to a fixed power, we get another GP. For example, if you have a GP 2, 4, 8, and so on, and if you raise each term to power 2, we'll still get a GP. If A, B, and C are in GP, then log A, log B, log C, they will be in AP, and vice versa. Three terms in GP should preferably be taken as A over R, A, and AR if the product of terms is given. Otherwise, we can also choose them as A, AR, and AR square. Similarly, if the product of terms is given, the four terms in GP should be taken as A over R cube, A over R, AR, and AR cube. Find four numbers in GP whose sum is 85 and their product is 4096. As the product of terms is given, so we will assume the terms as A over R cube, A over R, AR, and AR cube. As the product is given as 4096, when you multiply these terms, R will cancel out. So we'll have A to the power 4 is equal to 4096. 4096 is same as 8 raised to the power 4. That means A is equal to 8. Now we know the value of A. The second condition which is given is the sum of these terms is 85. A over R cube plus A over R plus AR plus AR cube is equal to 85. We can take A common. So A common 1 over R cube plus 1 over R plus R cube is equal to 85. Now let's substitute the value of A as 8 and regroup the terms inside the bracket. So it will be R cube plus 1 over R cube, R plus 1 over R. And if we take 85 on the other side, so it will be negative 85 is equal to 0. Here, R cube plus 1 over R cube is in the form of A cube plus B cube, which is same as A plus B whole cube minus 3ab times a plus b. So we can replace r cubed plus 1 over r cubed by using this formula. So it will be r plus 1 over r whole cube minus 3 times r plus 1 over r. So the equation becomes 8 times r plus 1 over r cubed minus 3 times r plus 1 over r plus r plus 1 over r minus 85 is equal to 0, which gives us 8 times r plus 1 over r cubed minus 16 times r plus 1 over r minus 85 is equal to 0. If we assume r over 1 plus r equals x, this equation will become 8x cubed minus 16x minus 85 is equal to 0. And now we can factorize this equation. We got the equation 8x cubed minus 16x minus 85 is equal to 0. If we factorize this equation, we'll get 2x minus 5 times 4x squared plus 10x plus 17 is equal to 0. If we equate both of them equal to 0, we'll get x is equal to 5 over 2. And from the second equation, if we equate it to 0, the values of x will be imaginary. So we'll reject that. So we get the value of x as 5 over 2. So we have r plus 1 over r is equal to 5 over 2. And if we take LCM here, we'll get r squared plus 1 over r is equal to 5 over 2, and which gives us the equation 2r squared minus 5r plus 2 is equal to 0. So 2r squared minus 5r plus 2 is equal to 0. And if we factorize this, we will get r minus 2 times 2r minus 1 is equal to 0. So from here we get r is equal to 2 or r is equal to 1 over 2. And we already know the value of a is 8. The four terms that we assumed were a over r cubed, a over r, ar, and ar cubed. When a is 8 and r is 2, the numbers will be 8 over 2 cubed, which is 8, 8 over r, which is 2, 8 times r, and 8 times r cubed. We have 1, 4, 16, and 64. When a is 8 and r is 1 over 2, the numbers will be 64, 16, 4, and 1. Three non-zero numbers a, b, and c are in AP. Increasing a by 1, the numbers are in GP, or increasing c by 2, the numbers are in GP. So there are two conditions given. Find the value of b. So we are given that a, b, and c are in AP. If they are in AP, that means 2 times b is equal to a plus c. So we have one condition. Second, it is given that if a is increased by 1, so a plus 1, b and c, they are in GP. So from here, we can say that b square is equal to a plus 1 times c. So that's the second condition. Third, it is given that if you increase c by 2, so a, b, and c plus 2, they are also in GP. From here, we can say that b square is equal to the first term a times the last term, which is c plus 2. And that's equation 3. From equation 2 and 3, we have the values of b square, which was a plus 1 times c, and from equation 3 it is a times c plus 2. So if we solve this, we get ac plus c is equal to ac plus 2a. We can cancel out ac. That means c is equal to 2a. So we got one more piece of information that c is equal to 2a. So we have c is equal to 2a. Equation 2 was b square is equal to a plus 1 times c. So if we use this value here, we'll get b square is equal to a plus 1 times 2a. And from equation 1, we had 2b is equal to a plus c. And if we use the value of c in equation 1, we'll get 2b is equal to a plus 2a. That gives us 2b is equal to 3a, or b is equal to 3a over 2. Now let's use this value of b equals 3a over 2 in this equation here. And that will give you 3a over 2 whole square is equal to a plus 1 times 2a. And this gives us 9a square over 4 is equal to a plus 1 times 2a. We can cancel out 1a. So we have 9a over 4 is equal to 2a plus 2. And if you multiply both sides by 4, we'll get 9a is equal to 8a plus 8. And from here, we get the value of a is equal to 8. Now we know the value of a, that a is equal to 8. And b was equal to 3a over 2. So 3 times 8 over 2, and that is 24 over 2, or 12. So the value of b is 12. And in the same way, if we are asked to find the value of c, we can find the value of c as well. Let a, g, and b be three terms in GP. As they are in GP, the common ratio of second and the first term should be same as the ratio of third term to the second term. And from here, we can say that g square is equal to ab, or g is equal to square root ab. Here, g is known as the geometric mean between a and b. In similar manner, if we have two numbers a and b, and in between these, if we insert n numbers g1, g2, g3, and so on up to gn, such that the resulting sequence is a GP, then these n numbers g1, g2, g3, and so on up to gn, they are known as the GMs between a and b. One thing to notice here is that a and b, these are two numbers, and we have inserted n numbers in between them, right? So there are n plus 2 total terms here. So we can say that b is the n plus 2 term. And the formula for n plus 2 term will be a times r to the power n plus 2 minus 1, which gives us n plus 1. And from here, we can say that b over a is equal to r raised to the power n plus 1, or r is equal to b over a raised to the power 1 over n plus 1. This formula helps us to find the values of g1, g2, g3, and so on up to gn. Let's look at one example to insert few GMs between two numbers. So if we have two numbers 2 and 486, and we want to insert 4 GMs between them, so it will be G1, G2, G3, and G4. Using the formula R equals B over A raised to the power 1 over n plus 1, we can find the value of R. Here, the value of B is 486. value of A is 2, value of n, which is the number of GMs, so 1 over 1 plus 4, that is 5. So you have 243 raised to the power 1 over 5. 243 can also be written as 3 raised to the power 5, and that is raised to the power 1 over 5. So r is equal to 3. So now we know the value of r as 3. The value of first term here is 2. So we can find G1. G1 is equal to AR. So that is 2 times 3 or 6. G2 is AR squared. So that is 2 times 3 squared. So that is 18. G3 is AR cubed. So that is 2 times 3 cubed. And that's 54. G4 is AR raised to the power 4. That is 2 times 3 to the power 4. And that is equal to 162. For what value of n, a raised to the power n plus 1 plus b raised to the power n plus 1 over a raised to the power n plus b raised to the power n is a GM between a and b? We know that the GM between a and b is given as square root ab. So in this case, we want to find that for what values of n, this will be equal to a raised to the power n plus 1 plus b raised to the power n plus 1 over a raised to the power n plus b raised to the power n. Square root ab can also be written as ab raised to the power 1 over 2 or a raised to the power 1 over 2 times b raised to the power 1 over 2. And we can multiply a raised to the power n plus b raised to the power n on the left hand side. So it will be a raised to the power n plus b raised to the power n. And on the right hand side, we can write it as a raised to the power n plus 1 plus b raised to the power n plus 1. Simplifying further, the left hand side can also be written as a raised to the power half plus n times b raised to the power half plus a raised to the power half times b raised to the power half plus n. And on the right hand side, we have a raised to the power n plus 1 plus b raised to the power n plus 1. Rearranging the terms here, we get a raised to the power half plus n times b raised to the power half minus a raised to the power n plus 1 is equal to, if we take this term on the other side, so we have b raised to the power n plus 1 minus a raised to the power half times b raised to the power half plus n. On the left hand side, we can take a raised to the power half plus n common. So we'll have b raised to the power half minus a raised to the power half. And on the right hand side, we can take b raised to the power half plus n common. So we'll be left with b raised to the power half minus a raised to the power half. We can cancel out b raised to the power half minus a raised to the power half on both sides. This gives us a raised to the power half plus n is equal to b raised to the power half plus n, which can also be written as a over b raised to the power half plus n equals 1. And that can also be written as a over b raised to the power n plus half is equal to a over b raised to the power 0. Equating the powers, we get n plus half is equal to 0 or n is equal to negative 1 over 2. The relationship between arithmetic mean and geometric mean. If we have two non-zero numbers a and b, the arithmetic mean between these two numbers we write as a is given as a plus b over 2, and the geometric mean is given as square root ab. If you find a minus g, that will be equal to a plus b over 2 minus square root ab, and that is a plus b minus 2 square root a times square root b over 2, which can also be written as a minus g is equal to square root a square plus square root b square minus 2 times square root a times square root b over 2. And the right hand side can also be written as square root a minus square root b over square root 2 whole square. as the right hand side is a square which is non-negative. So that means this is greater than or equal to 0, means a minus g is greater than equal to 0, or a is greater than equal to g. And that proves that am of any two numbers is greater than equal to their gm. So we found a relationship between am and gm is that am is greater than equal to gm. There's one more result that we can generate from here, that value of a and b in terms of arithmetic mean and geometric mean. So we know that the arithmetic mean is a plus b over 2. That means 2a is same as a plus b. And geometric mean g is square root ab. That means g square is equal to ab. If I write an equation x square minus a plus b times x plus ab equals 0. This is a quadratic equation. And here a plus b can be replaced with 2a and ab can be replaced with g square. So x squared minus 2a times x plus g square is equal to 0. And if by quadratic formula you find the roots of this equation, they will be a plus minus square root of a square minus g square. These are the values of x. But the initial equation was x square minus a plus b times x plus ab. And the roots of this equation are x is equal to a and b. Therefore, we can say that a is equal to a plus square root a square minus g square, and b is equal to a minus square root a square minus g square. If the am and gm between two numbers are in the ratio m is to n, then prove that the numbers are in the ratio m plus square root m square minus n square is to m minus square root n square minus n square. If we assume the numbers as a and b, we are trying to prove a over b is equal to m plus square root m square minus n square over m minus square root m square minus n square. So this is what we want to prove. And what is given is that ratio of am to gm is m over n. From the previous discussion, we know that a can be written as a plus square root a square minus g square, where capital A is the am and g is the gm. And b can be written as a minus square root a square minus g square. And in this case, it is given that the ratio of a is to g is m is to n. For any value k, we can say that a is equal to m times k and g is equal to n times k. So we have the value of a and g. So we can find a over b. A over b is a plus square root a square minus g square over a minus square root a square minus g square. We can substitute the value of a, which is mk, plus square root m square k square minus n square k square over mk minus square root m square k square minus n square k square. And here from the numerator and denominator, we can take out k common and it will cancel out. So you have m plus square root m square minus n square over m minus square root m square minus n square. Sum of terms of a GP. If you have a GP, the sum of these terms can be written as Sn. If we multiply equation 1 throughout by r, we get r times Sn is equal to ar plus ar square plus so on up to ar raised to the power n minus 1 plus ar raised to the power n. And if we subtract these two equations, ar will cancel out, ar square will cancel out, ar raised to the power n minus 1 will cancel out. So you'll be left with Sn minus r times Sn is equal to a minus a times r raised to the power n. On the left hand side, you can take Sn out, so we'll be left with 1 minus r, and on the right hand side, you can take a common, so you'll have 1 minus r raised to the power n. And dividing both sides by 1 minus r, we'll get Sn is equal to a times 1 minus r raised to the power n divided by 1 minus r. By taking negative sign common from the numerator and denominator, the above result can also be written as a times r raised to the power n minus 1 over r minus 1. So we can use these two formulae for sum of n terms of a GP. One thing to notice here is that r should not be equal to 1. If r is 1, then this formula is not defined. For r equals 1, the sum of n terms is given as a times n. Find the number of terms in a GP if a1 is equal to 3, an is equal to 96, and sum of n terms is 189. So we are given with an equals 96. The formula for nth term of a GP is a times r raised to the power n minus 1. This is given as 96. We know the value of a or a1, which is 3. So 3 times r to the power n minus 1 is equal to 96. Dividing both sides by 3, we get r raised to the power n minus 1 is equal to 96 over 3 or 32. So we got the value of r raised to the power n minus 1 is equal to 32, which can also be written as r raised to the power n over r is equal to 32, or r raised to the power n is same as 32 times r. Now we are also given with Sn is equal to 189. The sum of n terms formula for a GP is a times 1 minus r to the power n over 1 minus r. And that is given equal to 189. We know the value of a, which is 3, times 1 minus r raised to the power n we found is equal to 32r. So 32r divided by 1 minus r is equal to 189. We can cancel out 3 and 189, we'll get 63 on the right hand side, and then we can multiply 1 minus r on the right hand side. So we get 1 minus 32r is equal to 63 times 1 minus r, which is same as 1 minus 32r is equal to 63 minus 63r, or 63r minus 32r is equal to 63 minus 1, which is same as 31r is equal to 62, or r is equal to 2. And now we know the value of r, and we found that r raised to the power n was equal to 32r. That means 2 raised to the power n is equal to 32 times 2, so 64, which is same as 2 to the power 6. Therefore, n is equal to 6. Let S be the sum, P be the product, and R be the sum of reciprocals of n terms of a GP. Prove that P square times R raised to the power n is equal to S raised to the power n. So S is equal to A times 1 minus R raised to the power n over 1 minus R. We are also given with that P is the product of n terms. So P is equal to A times AR times AR squared, and so on up to AR raised to the power n minus 1. So here A is multiplied n times. So A raised to the power n times R raised to the power, the powers will add up. So it will be 1 plus 2 plus 3 and so on up to n minus 1. Here 1 plus 2 plus 3 plus so on up to n minus 1. This is an AP, and we can find the sum of this by using the sum of AP formula, which is the number of terms. Here number of terms will be n minus 1. So n minus 1 over 2 times the first term, which is 1, plus the last term, which is n minus 1. We can cancel out 1. So it will be n times n minus 1 over 2. Therefore, P is equal to A raised to the power n times R raised to the power n times n minus 1 over 2. Now, R is the sum of reciprocals. So R is equal to 1 over A plus 1 over AR plus 1 over AR square and so on up to 1 over AR raised to the power n minus 1. This is also a GP in which the first term is 1 over A and the common ratio is 1 over R. So the sum will be 1 over A times 1 minus 1 over R raised to the power n divided by 1 minus 1 over R. If we simplify this, we get R raised to the power n minus 1 over A times R raised to the power n minus 1 times R minus 1. So now we know the values of S, P, and R. S is equal to A R raised to the power n minus 1 over R minus 1. P is equal to A raised to the power n R raised to the power n times n minus 1 over 2. And R is equal to R raised to the power n minus 1 over A times R raised to the power n minus 1 times R minus 1. And if we start with the left-hand side, which is P square times R raised to the power n, which will be equal to P square. So A raised to the power 2n, R raised to the power n times n minus 1 times R raised to the power n will give us R raised to the power n minus 1 raised to the power n divided by the denominator raised to the power n. So A raised to the power n, R raised to the power n times n minus 1 times R minus 1 raised to the power n. We can cancel out R raised to the power n times n minus 1. 1 of A raised to the power n will cancel out. So we'll be left with A raised to the power n times R raised to the power n minus 1 whole raised to the power n divided by R minus 1 raised to the power n, which is nothing but same as S raised to the power n, and that is equal to the right hand side. Find the sum of the series 11 plus 103 plus 1005, so on up to n terms. Here we are given with a series which is not AP or GP. But if we look carefully, we can write 11 as 10 plus 1. We can write 103 as 100 plus 3. 1005 as 1000 plus 5, and so on. Similarly, the last term, the nth term, can be written as 10 to the power n plus. The second part here is an odd number. Therefore, the last term will be 2n, which is even, minus 1, an odd number. Now, if we write all powers of 10 together, so it's 10, 100, which is 10 to the power 2, 1000, which is 10 to the power 3, and so on, up to 10 raised to the power n. This is a GP. And the second part, which is 1, 3, 5, and so on, up to 2n minus 1, it's an AP. So for the first one, we will apply the sum of GP formula. For the second one, we'll apply the sum of AP formula. Applying sum of GP formula, we'll get A, which is 10, R raised to the power n, which is 10 to the power n minus 1 over 10 minus 1. Plus, for sum of AP, n over 2, first term plus the last term. And if we simplify this, we get 10 over 9, 10 raised to the power n minus 1, plus n over 2 times 2n, because 1 will cancel out. So n over 2 times 2n is same as n squared. So plus n squared. Find the sum of the series 5 plus 55 plus 555 plus 5555 and so on up to n terms. So this sequence is not a GP or an AP, but if we take 5 common, we can write it as 1 plus 11 plus 111 plus and so on. And if we multiply this by 9 and divide by 9, we get 5 over 9, 9 plus 99 plus 999, and so on up to n terms. Now, 9 can be written as 10 minus 1. 99 can be written as 100 minus 1. Also, 100 can be written as 10 square, so 10 square minus 1. Similarly, 999 can be written as 10 cube minus 1, and so on. Here, the first parts, 10, 10 square, 10 cube, and so on, they form a GP. -1, -1, -1, that will be added n times. So you have 5 over 9, 10 plus 10 square plus 10 cube, and so on. There are n terms, and -1 plus 1 plus 1, so on. This is also n terms. For the first part, we will apply sum of GP formula, which is A times R. Here R is 10 square divided by 10, which is 10. So 10 raised to the power n minus 1 over 10 minus 1. Minus 1 added n times is equal to n. So you have 5 over 9, 10 over 9 times 10 raised to the power n minus 1 minus n, which can also be written as 5 over 81, 10 raised to the power n plus 1 minus 10 minus 9n. If f is a function satisfying f of x plus y equals f of x times f of y for all x and y belonging to natural numbers, and it is given that f of 1 is equal to 3, and f of 1 plus f of 2 plus f of 3, and so on up to f of n is equal to 120. Find the value of n. Here we are given with f of x plus y equals f of x times f of y, and we are also given with value of f of 1, which is 3. If we replace x and y with 1, because x and y belong to natural numbers, so if I start with natural number 1, we get f of 1 plus 1, which is 2, is equal to f of 1 times f of 1. So that is 3 times 3, or 3 square. Similarly, f of 3, which can be written as f of 1 plus 2. So if you take x as 1, y as 2, we get f of 1 times f of 2. So here f of 1 is 3 times f of 2 is 3 square. So you get 3 cube, right? Similarly, we can find f of 4, that it will be equal to 3 raised to the power 4. And similarly, we can find the value of f of n, that f of n will be equal to 3 raised to the power n. Now it is given that the sum of all these terms is equal to 120. So f of 1 plus f of 2, and so on up to plus f of n is equal to 120. F of 1 is 3, f of 2 is 3 square, and so on up to 3 raised to the power n, and that is given equal to 120. So this is a GP in which the first term a is 3. The common ratio is 3 square over 3, which is again 3, and number of terms is n. So the sum of these terms is equal to a times r, which is 3 raised to the power n minus 1 over r minus 1, so 3 minus 1, and that is equal to 120. And if we simplify this, we get 3 over 2 times 3 raised to the power n minus 1 is equal to 120. And we can simplify this further. 3 raised to the power n minus 1 is equal to 120 times 2 over 3. And if I simplify this, we can cancel these out. So you have 40, that is 80. And that means 3 raised to the power n is equal to 81. And that's 3 raised to the power n is equal to 3 raised to the power 4, or n is equal to 4. Using the sum of GP, prove that a raised to the power n plus b raised to the power n, where a, b, n all are natural numbers, is divisible by a plus b for odd natural numbers, only for odd natural numbers. And hence prove that 1 raised to the power 99 plus 2 raised to the power 99 and so on up to plus 100 raised to the power 99 is divisible by 10100. Here we want to prove that a raised to the power n plus b raised to the power n is divisible by a plus b. In order to prove that a raised to the power n plus b raised to the power n is divisible by a plus b, we need to prove that the result of this expression should be an integer. We can manipulate this expression by taking a raised to the power n common from the numerator. So we'll have 1 plus b raised to the power n over a raised to the power n divided by, and from the denominator, if I take a common, it will be 1 plus b over a, right? And which can also be written as a raised to the power n minus 1 by dividing a raised to the power n with a by using exponent formulas. And here, if we write 1 minus b over a raised to the power n, it will not affect the final result because we are talking about odd natural numbers. So if n is equal to, let's say, 1, then it will give you the result as 1 plus b over a, right? Because this will be negative b over a. This is negative, correct? Okay. And the denominator, again, it can also be written as 1 minus b over a. And that is same as a raised to the power n minus 1 times 1 multiplied by 1 minus negative b over a raised to the power n over 1 minus negative b over a. Now this is in the form of a times 1 minus r raised to the power n over 1 minus r, correct? Here a is 1 and r is equal to negative b over a, correct? And now you get the reason why we wrote negative and negative b over a, because we wanted to use the formula for sum of GP. So now we have sum of GP formula, and we can go in the reverse order. From the sum of GP formula, we can write the series. So a raised to the power n minus 1 times the first term is 1 and the common ratio is negative b over a. So the second term will be a times r, so plus a times r. The next term will be a times r raised to the power 2. The next term will be a times r raised to the power 3, and so on, right? So this is a raised to the power n minus 1, 1 minus b over a plus b square over a square minus b cube over a cube, and so on. Which can also be written as a raised to the power n minus 1 if you multiply a raised to the power n minus 1 inside. So we have a raised to the power n minus 1 minus b times a raised to the power n minus 2, because a raised to the power n minus 1 divided by a will give you a raised to the power n minus 2. Similarly, the next term will be b square times a raised to the power n minus 3, and so on. As we know that a, b, and n all are natural numbers. So this expression here will give you an integer answer always. As this represents an integer and there will be no remainder left, therefore we can say that a raised to the power n plus b raised to the power n is divisible by a plus b. Now moving on to the second part of proving 1 raised to the power 99 plus 2 raised to the power 99, so on up to 100 raised to the power 99 is divisible by 10100. Here we can use the fact that a raised to the power n plus b raised to the power n is divisible by a plus b if n is odd. In order to prove that this expression is divisible by 10100, which is basically 101 times 100, we can prove that this expression is divisible by 101 and 100. So let's do it. We can regroup the terms as 1 raised to the power 99 plus 100 raised to the power 99 plus 2 raised to the power 99 plus 99 raised to the power 99 and so on, right? So here each group is in the form of a raised to the power n plus b raised to the power n. So it will be divisible by a plus b, right? Here a plus b gives you 101. So that means this total expression will be divisible by 101. And in the similar manner, we can regroup the terms as 1 raised to the power 99 plus 99 raised to the power 99 plus 2 raised to the power 99 and 98 raised to the power 99 and so on. But there will be two terms left out, which are 50 raised to the power 99 and 100 raised to the power 99. So the first group is divisible by 100, second group is divisible by 100, and all the groups will be divisible by 100. 100 raised to the power 99 is also divisible by 100, and 50 raised to the power 99 is also divisible by 100. So here all the groups are divisible by 100. Now we have proved that 1 raised to the power 99, 2 raised to the power 99, and so on up to 100 raised to the power 99. This series is divisible by 100 as well as 101. So therefore it is divisible by 10100. We know that sum of n terms of a GP is given as a times 1 minus r raised to the power n over 1 minus r, which can also be written as a minus a raised to the power n over 1 minus r, or a over 1 minus r minus a r raised to the power n over 1 minus r. If there are infinite number of terms in the GP, that means n tends to infinity and the absolute value of the common ratio is less than 1. In that case, r raised to the power n will tend to 0. So as r raised to the power n tends to 0, this part here will become 0. So we will be left with a over 1 minus r. Sum of infinite number of terms will be equal to a over 1 minus r, provided the modulus r or absolute value of r is less than 1. Let's find the sum of this series. 1 over 2 plus 1 over 3 squared plus 1 over 2 cubed plus 1 over 3 raised to the power 4 plus 1 over 2 raised to the power 5 plus 1 over 3 raised to the power 6 and so on up to infinity. Here we have two different series. One is 1 over 2 plus 1 over 2 cubed plus 1 over 2 raised to the power 5 and so on up to infinity. And the second one is 1 over 3 squared plus 1 over 3 raised to the power 4 and so on up to infinity. For the first one, 1 over 2 plus 1 over 2 raised to the power 3 plus 1 over 2 raised to the power 5 and so on up to infinity. Here a is 1 over 2, and the common ratio is 1 over 2 cubed divided by 1 over 2. So A2 over A1, and which gives us 1 over 2 square or 1 over 4. So sum of this particular series, I am calling it as series 1. So sum of this series will be A over 1 minus R. So that is half over 1 minus 1 over 4. That is half over 4 minus 1 over 4. That is 3 over 4, which is same as 1 over 2 times 4 over 3. And that's 2 over 3. Similarly, for the second part, we had 1 over 3 squared plus 1 over 3 raised to the power 4 plus 1 over 3 raised to the power 6 and so on up to infinity. Here A is equal to 1 over 3 squared, so 1 over 9, and R is equal to 1 over 3 raised to the power 4 divided by 1 over 3 squared, which is same as 1 over 3 squared, or we can say 1 over 9. So the sum of this series will be equal to A 1 over 9 over 1 minus R. So 1 over 9. So that's 1 over 9 divided by 8 over 9 or 1 over 8. So now we know the value of S1 and S2, and that will give you the answer. So it is 2 over 3 plus 1 over 8, which is same as 19 over 24. A ball is dropped from a height of 120 meters. After striking the floor, the ball rebounds 4/5 of the height from which it was dropped. And find the total distance that it travels before coming to rest. Here we are given where that a ball is dropped from a height of 120 meters. So it travels 120 meters and then it rebounds 4/5 of 120. And from here it comes back again the same distance, and then it rebounds 4/5 of this distance. So it rebounds 4/5 of 4 over 5 times 120. And this process continues until the ball comes to rest. So we can say that the total distance covered is equal to 120 plus 2 times 4 over 5 times 120 plus 4 over 5 square times 120 plus 4 over 5 cube times 120 and so on up to infinity. And that is equal to 120 plus 2 times, and the series that we got here is Infinite G.P, whose sum is A, which is 4 over 5 times 120 over 1 minus R. And R here is 4 over 5. So 4 over 5, which is equal to 120 plus 2 times 4 times 120 over 5 divided by 1 over 5. We can cancel out 5. So that is 120 plus 2 times 480. And that's 120 plus 960 or 1080 meters. An arithmetico-geometric progression. So it's a combination of an AP and a GP. For example, 1 times 4, 3 times 4 square, 5 times 4 cube, and so on. Here, the first part of every term, 1, 3, 5, and so on, this forms an AP. The second parts here, 4, 4 square, 4 cube, and so on, they form a GP. And such a progression is known as A.G.P. Let's look at an example where we need to find the sum of an A.G.P. So we have the A.G.P as 2017 plus 1 over 4 times 2016 plus 1 over 4 times 2015 plus and so on up to 1 over 4 times 2 plus 1 over 4 times 1. This series can also be written as 2017 plus 1 over 4 times 2016 plus 1 over 4 squared times 2015 and so on up to 1 over 4 raised to the power 2016 times 1. Here the terms 2017, 2016, 2015 and so on, they form an AP. So for the AP, we have A equals 2017. The common difference is subtracting 2016 and 2017, we get -1. So D is -1. For the GP, the first term here is times 1. So A is equal to 1. And the common ratio is the second term divided by the first term. So it is 1 over 4. And the sum of series that we want to find out, we can call it as S. Whenever you need to find the sum of an A.G.P, what we do is after you find the common ratio of the GP, you multiply the given series with R throughout. So multiplying throughout by R, we get 1 over 4 times S is equal to 2017 times 1 over 4 plus 1 over 4 square times 2016 plus 1 over 4 cube times 2015 and so on. And the last term now will be 1 over 4 raised to the power 2017 instead of 16 times 1. So we can call this as equation 2, and we had equation 1 as S equals 1 times 2017 plus 1 over 4 times 2016 and so on. The last term was 1 over 4 raised to the power 2016 times 1. That was equation 1. So subtracting equation 2 from equation 1, what we get is S minus 1 over 4S, that is 3 over 4 times S, is equal to, here what we do, we club the terms with same GP terms. So 1 over 4 times 2016 and 1 over 4 times 2017. Similarly, 1 over 4 square times 2015 and 1 over 4 square times 2016 and so on. So 2017 as it is, this minus this, which was same as 1 over 4 times 2016 minus this, so it is -1. Similarly, 1 over 4 square, it will be 2015 minus 2016, again -1, and so on. And the last term will be, -1 over 4 raised to the power 2017. So you have 3 over 4 times S is equal to 2017 minus, we have a series 1 over 4 plus 1 over 4 square and so on up to 1 over 4 raised to the power 2017. This is a GP for which we can apply the sum of GP formula. So you have 3 over 4 times S is equal to 2017 minus, applying the sum of GP formula, A is 1 over 4, 1 over 4 times 1 minus R is again 1 over 4 raised to the power N, which is 2017. So 2017 over 1 minus R, so 1 minus 1 over 4. Simplifying this, we get 3 over 4 times S is equal to 2017 minus 1 over 3 times 1 minus 1 over 4 raised to the power 2017. And we can multiply both sides by 4 over 3 to get rid of just 3 over 4. So S is equal to 4 over 3 times 2017 minus 4 over 9 times 1 minus 1 over 4 raised to the power 2017. And that gives you the sum of this series. If the sum to infinity of the following series is 14 over 9, find the value of D. So we are given with the series 3 plus 3 plus d times 1 over 4, 3 plus 2d times 1 over 4 square, and so on up to infinity. We can call this series as S. Here, the AP part is 3, 3 plus d, 3 plus 2d, and so on. This is the AP portion of this series. And the GP part of this series is 3 is 3 times 1, so 1, 1 over 4, 1 over 4 square, and so on up to infinity. Here, the value of A is 3, and D is given as D. And here A is 1, and the common ratio is 1 over 4. Whenever we are given with A.G.P and we want to find the sum, we find R, we multiply the given series by R. So you multiply the given series by R, so it will be 1 over 4 times S is equal to 3 times 1 over 4 plus 3 plus D times 1 over 4 squared, 3 plus 2D times 1 over 4 cubed, and so on up to infinity. And then you subtract equation 2 from equation 1. So if we subtract equation 2 from equation 1, we club the terms with same GP parts. So 3 plus D times 1 over 4 minus 3 times 1 over 4. 3 plus 2D times 1 over 4 square will be clubbed with 3 plus D times 1 over 4 square. So if you keep the first term as it is, and the last term, if it is not up to infinity, as it is. So subtracting these two, we get 3 over 4 times S is equal to 3 plus, so it was 3 plus D minus 3 times 1 over 4 plus 3 plus 2D minus 3 plus D, so minus 3 minus D times 1 over 4 square, and so on up to infinity. That is same as 3 over 4 times S, 3 plus, here 3 will cancel out, so you have D times 1 over 4. Second part will be, again 3 will cancel out, and 2D minus D is D, so it's D times 1 over 4 square, and so on. So you have 3 over 4 times S is equal to 3 plus D common from these terms. We have 1 over 4 plus 1 over 4 square, and so on up to infinity. This is infinite GP. And for infinite GP, the sum of terms is given as A. A here is 1 over 4 over 1 minus R. So 1 minus R is also 1 over 4 in this case. 1 over 4. And if you simplify, this will be 3 plus D times 1 over 4 divided by 3 over 4. 1 over 4 divided by 3 over 4 is 1 over 3. So it's D over 3. So from here we get 3 over 4 S is equal to 3 plus D over 3. We are given with the value of sum of the series. That sum of the series is 44 over 9. That is equal to 3 plus D over 3. We can take 3 on the other side and multiply both sides by 3 to get rid of this 3, right? So 3 over 4 times 44 over 9 minus 3 multiplied by 3 is equal to the value of D. And we can simplify this further. So we can cancel out 4 and 44, that is 11. We can cancel 3 and 9. So you get 11 over 3 minus 3 times 3. That's the value of D. Simplifying it further, you get 11 minus 9, that is 2. So the value of D is 2. If we have a series S of n as t1 plus t2 plus so on up to tn, the sum of n terms of any series, this can be represented as sigma or summation or r equals 1 to n of tr. So this expression and the first equation on the right hand side, they have the same meaning. Few properties to know about sigma notation is that if you have something like sigma r equals 1 to n, of TR plus or minus TR dash, then we can write it as sigma R equals 1 to n of TR plus or minus sigma R equals 1 to n for TR dash. So sigma notation can be distributed over plus or minus. But if you have something like R runs from 1 to n, TR times TR dash, or if you have sigma R equals 1 to n TR over TR dash, then this is not distributive. So you cannot write sigma R equals 1 to n TR times sigma R equals 1 to n TR dash. Similarly, in the division, you cannot write sigma R equals 1 to n TR over sigma R runs from 1 to n for TR dash. So these two are not possible. So sigma notation is distributive over plus and minus, but not multiplication and division. Sum of squares of first n natural numbers. So sum of 1 square plus 2 square plus 3 square and so on up to n square. In order to find this sum, we can start with the formula that a minus 1 whole cube is same as a cube minus 3a square plus 3a minus 1. And from here, I can say that a cube minus a minus 1 cube is same as 3a square minus 3a plus 1. Starting with this identity, if we replace a with 1, 2, 3, and so on up to n, let's see what we get. If we replace a with 1, we get 1 cube minus 0 cube is equal to 3 times 1 square minus 3 times 1 plus 1. If we replace a with 2, we'll get 2 cube minus 1 cube is equal to 3 times 2 square minus 3 times 2 plus 1. Similarly, replacing a with 3, we get 3 cube minus 2 cube is equal to 3 times 3 square minus 3 times 3 plus 1, and so on. The last term will be n cube minus n minus 1 cube is equal to 3 times n square minus 3 times n plus 1. If we add all these terms, you'll see that 1 cube will cancel out, 2 cube will cancel out. Similarly, 3 cube will cancel out, and n minus 1 cube will also cancel out. So on the left hand side, we'll be left with n cube. And on the right hand side, we can add all the terms with square. So 3 times 1 square plus 2 square and so on up to n square. Similarly, negative 3 times 1 plus 2 plus 3 and so on up to n. And 1 added n times is n, which can be written as n cube is equal to 3 times, this is what we want to find, and we called it as s, so 3s minus 3 times 1 plus 2 plus so on up to n. This is an AP with n terms. So we can find the sum easily. It is n over 2, the first term plus the last term plus n. From here, we can take this term and n on the other side. So 3s is equal to n cube. 3s is equal to n cube plus 3 over 2 times n plus 1 minus n. If we simplify this further, we get s is equal to n plus 1 times 2n plus 1 times n over 6. Sum of cubes of first n natural numbers. As we discussed the sum of squares of first n natural numbers, similarly we can start with the relation that a raised to the power 4 minus a minus 1 raised to the power 4 is same as 4 times a cube minus 6a square plus 4a minus 1. And if we replace a as 1, 2, 3, and so on up to n, we will get 1 to the power 4 minus 0 to the power 4 is equal to 4 times 1 cube minus 6 times 1 square plus 4 times 1 minus 1. Replacing it with 2, we'll get 2 raised to the power 4 minus 1 raised to the power 4 is equal to 4 times 2 cube minus 6 times 2 square plus 4 times 2n minus 1. Similarly, the last one will be n raised to the power 4 minus n minus 1 raised to the power 4 is equal to 4 times n cube minus 6 times n square plus 4 times n minus 1. Adding all these terms, we'll see that all the terms will cancel out on the left hand side except n to the power 4. So we have n to the power 4 is equal to 4 times 1 cube plus 2 cube and so on up to n cube minus 6 times 1 square plus 2 square and so on up to n square plus 4 times 1 plus 2 plus so on up to n and negative 1 added n times, so that is negative n. We can write it as n raised to the power 4 is equal to 4 times what do we want to find, the sum of cubes, so we can call it as s, 4 times s, negative 6 times, we know the sum of squares of first n natural numbers, so we can use the formula n times n plus 1 times 2n plus 1 over 6 plus 4 times the sum of first n natural numbers. We can find it by using sum of AP formula, which is n plus 1 over 2 minus n. Simplifying this relation will give us s is equal to n square times n plus 1 square over 4, which can also be written as n times n plus 1 over 2 whole square. Find the sum to n terms of 2 times 5 plus 5 times 9 plus 8 times 13 plus 11 times 17 and so on. Here we have a series which is not an AP. It's not a GP. It is not A.G.P, not Arithmetico-Geometric progression. It is a combination of two APs. So here the first parts 2, 5, 8, 11 and so on, they form an AP. Similarly 5, 9, 13, 17 and so on, they also form an AP. For first AP, which is 2, 5, 8, 11 and so on, here A is 2, D is 3. So the last term, which is AN, will be equal to A plus n minus 1 D. So A is 2, n minus 1 and D is 3, so 3. And if we simplify this, we'll get 3n minus 1. So that's the nth term of the first part. Similarly, the second parts 5, 9, 13, 17 and so on. Here the nth term will be A, which is 5, plus n minus 1 times D is 4 here, 9 minus 5, right? So 4. And if we simplify this, we get 4n plus 1. That's the nth term of the second parts. Combining these two will get the nth term of this series. So nth term of the given series is 3n minus 1 times 4n plus 1. And in order to find the sum of this series, we can find the summation of this term. So summation Tn. So it will be summation of this expression, which is 12n squared minus n minus 1, which can be written as 12 times summation of n squared minus 1 times summation n and summation 1. So it's 12 times summation n square is n times n plus 1 to n plus 1 over 6. Sum of first n natural numbers is n times n plus 1 over 2, and 1 added n times will be n. Simplifying this expression, we'll get n over 2 times 8n squared plus 11n plus 1. Find the sum of the series to n terms. 1 cube over 1 plus 1 cube plus 2 cube over 1 plus 3 plus 1 cube plus 2 cube plus 3 cube over 1 plus 3 plus 5 and so on up to n terms. If we find the rth term of this series, it will be 1 cube plus 2 cube plus 3 cube and so on up to r cube over 1 plus 3 plus 5 plus so on up to 2r minus 1. Here, the numerator is in the form of sum of cubes of r natural numbers. By applying the formula for that, we get r square, r plus 1 whole square over 4. And the denominator is in the form of an AP, whose first term is 1, the last term is 2r minus 1, and the common difference is 2. So we can find the sum of these terms. So r over 2 times first term plus the last term. And if you simplify this, you get r squared times r plus 1 whole square over 4 divided by the denominator. 1 will cancel out, this 2 will cancel out, we will have only r squared. So you can cancel out r squared. So you're left with r plus 1 whole square over 4. So rth term of the given series is r plus 1 whole square over 4. To find the sum of the series, we can take summation of this term. So taking summation r equals 1 to n of tr will give us the sum of the series. And on the right hand side, we can write summation r equals 1 to n r plus 1 whole square over 4. 4 is a constant, so we can take it out. So it will be 1 over 4 times summation of r plus 1 whole square. So 1 over 4, if you replace r with 1, we get 2 square, plus if you replace r with 2, we get 3 square, and so on up to n plus 1 whole square. In order to use the formula sum of squares of first n plus 1 natural numbers, what we can do is add and subtract 1 square. So if I add 1 square here and subtract 1 square, for the first n plus 1 terms, we can apply the formula and 1 square will be as it is. So it is the sum is equal to 1 over 4 times sum of squares of first n plus 1 natural numbers, which will be n plus 1, n plus 2, 2 times n plus 1 over 6 minus 1. Simplifying this, we'll get n times 2n squared plus 9n plus 13 over 24. Find the sum to n terms of the series 3 plus 15 plus 35 plus 63 and so on. This series is not an AP or GP, but if we find the difference of 15 and 3, that gives you 12. If you find the difference of 35 and 15, that gives you 20. Difference of 63 and 35 gives you 28. And now if you look at this new sequence of differences that we got, it is an AP because the common difference is the same. Whenever you have such a series in which the differences of successive terms form an AP, the nth term of such a sequence is given as an squared plus bn plus c. In order to find the sum of this series, what we can do is we know the first term, second term, and the third term. If we replace n with 1, we get t1 is equal to a times 1 square, so a, plus b times 1, which is b, plus c, but it is given as 3, so this is equal to 3. That's equation 1. And if you replace n with 2, we get 4a plus 2b plus c is equal to the second term, which is 15. Third term 9a plus 3b plus c is equal to 35. Now from here we can find the values of a, b and c. After we find the values of a, b and c, we will get the value of Tn, the nth term. And after we know what is Tn, we can take summation of Tn to find the sum of this series. So now let's find the values of a, b and c. In order to find a, b and c, we can subtract equation 1 from equation 2 and equation 2 from equation 3. If we subtract equation 1 from equation 2, we get 3a plus b is equal to 12. And subtracting equation 2 from equation 3, we get 5a plus b is equal to 20. We can call these two new equations as equation 4 and 5. So if I subtract equation 4 from equation 5, we will get 2a is equal to 8 or a is equal to 4. Now using this value of a in any of these equations, we will get the value of b. So if I use a equals 4 in equation 4 or equation 5, we will get the value of b as 0. So we got the value of b as 0, we got the value of a. Now we can find the value of c. A plus b plus c was equal to 3. A is 4, b is 0. So c is equal to 3 minus 4 or negative 1. So now we know the value of a, b and c. And Tn was equal to an square plus bn plus c. So that is 4n square plus b and b is 0. So that this part is 0 plus c, which is negative 1. So we found the nth term. And in order to find the sum, we can take summation of nth term. So summation of nth term, summation of 4n square minus 1. That is 4 times summation of n square minus summation of 1, which is n. So 4 times summation n square is n plus 1, 2n plus 1 over 6 minus n, which can be simplified further, which will give us n over 3 times 4n square plus 6n minus 1. Find the sum of the series to n terms 5 plus 7 plus 13 plus 31 plus 85 and so on. Here the given series is not in the form of AP or GP, but if we find the differences of consecutive terms, 7 minus 5 is 2, 13 minus 7 is 6, 31 minus 13 is 18, and so on. Here we'll find that the common difference of these terms is not same, so that means it's not AP. But if we find the ratio of 6 and 2 is 3, ratio of 18 and 6 is also 3. So we'll find that this sequence of differences is a GP. And whenever you have such cases where the differences form a GP, the nth term of such a sequence is given by the formula a times r raised to the power n plus b. In order to find the nth term, we need to find a and b. We already know r, that r is equal to 3, right? So Tn is equal to a times 3 to the power n plus b. If we replace n with 1, we get T1, which is 3a plus b, and that is given equals to 5. So that is 5. I can call this as equation 1. If we replace n with 2, so we get T2 equals 9a plus b, and that is given as 7. So that is 7. So we have two equations in two variables. Solving these two equations, we'll be able to get the value of a and b. If we subtract equation 1 from equation 2, we will get 6a is equal to 2 or a is equal to 1 over 3. We got the value of a as 1 over 3, and if we use this value in equation 1, which was 3a plus b equals 5, In this, if you use A as 1 over 3, you get 3 times 1 over 3 plus B is equal to 5, or B is equal to 5 minus 1, which is 4. So we got the value of A and B. Now we can find Tn. Tn was equal to A times 3 to the power n plus B. Replacing A and B here, we get 1 over 3 times 3 to the power n plus 4, which can also be written as 3 to the power n minus 1 plus 4. Now we know the nth term of this series. We can take summation of the nth term, and that will give you the sum of the series. So taking summation of nth term will give you the sum of the series. Summation 3 raised to the power n minus 1 plus 4. Here, summation of 4 means 4 added n times, so that gives you 4n, plus summation 3 raised to the power n minus 1. For this part, summation 3 raised to the power n minus 1 is same as 3 to the power 0 plus 3 to the power 1 plus 3 to the power 2 and so on, which is the GP, and sum of which can be found by using sum of GP formula. So we have the series as 1 plus 3 squared and so on, sum of which will be A, which is 1, times r raised to the power n. So r is 3 raised to the power n, minus 1 over r minus 1. So 3 minus 1. So we get 3 to the power n minus 1 over 2. Therefore, the sum of the series is 4n plus 3 raised to the power n minus 1 over 2, which can be simplified further, and we can write it as half times 3 raised to the power n plus 8n minus 1. Let's discuss the sigma notation for independent variables now. Find the sum of k from 1 to infinity, n from 1 to infinity of k over 2 raised to the power n plus k. K over 2 raised to the power n plus k can also be written as k over 2 raised to the power n times 2 raised to the power k by using exponent formula. So here we have two different variables, k, and then another variable is n. So this expression can be written as summation k equals 1 to infinity of k over 2 raised to the power k times summation n equals 1 to infinity of 1 over 2 raised to the power n, which is equal to summation k equals 1 to infinity k over 2 raised to the power k. And here if you replace n with 1, 2, 3 and so on up to infinity, we'll get 1 over 2 plus 1 over 2 squared plus and so on up to infinity. This is an infinite GP, so we can apply the formula for infinite GP. So it's summation k equals 1 to infinity k over 2 raised to the power k, and applying sum of infinite terms for GP, we get 1 over 2 divided by 1 minus 1 over 2. That's A over 1 minus R formula. And that will give you 1 over 2 divided by 1 over 2. So it will cancel out. So you're just left with summation k equals 1 to infinity of k over 2 raised to the power k. Now if you replace k with values 1, 2, 3 and so on up to infinity, we'll get 1 over 2 plus 2 over 2 squared plus 3 over 2 cubed and so on up to infinity. And this series is in the form of 1 times 1 over 2 plus 2 times 1 over 2 squared plus 3 times 1 over 2 cubed plus and so on up to infinity. So it's a combination of an AP and a GP, right? And in these cases, what we do is, in order to find the sum, we multiply the given series by the value of common ratio. Here the common ratio will be 1 over 2 square divided by 1 over 2, 1 over 2. So we multiply equation 1 by 1 over 2. So 1 over 2 times s is equal to 1 times 1 over 2 square plus 2 times 1 over 2 cube plus 3 times 1 over 2 raised to the power 4 and so on up to infinity. We can call this as equation 2. If we subtract equation 2 from equation 1, we will get half times the sum of the series is equal to 1 over 2 plus 1 over 2 squared plus 1 over 2 cube and so on up to infinity. Here the right hand side is infinite GP with first term A as 1 over 2 and R as 1 over 2. So if we apply the sum of GP formula for infinite terms, it is A 1 over 2 divided by 1 minus R is again 1 over 2. So it is 1. So half times S is equal to 1 or S is equal to 2. So sum of the series is 2. Sometimes it is not possible to directly take summation of a series. So what we do is we use the cancellation method. So we want to find the sum of this series, which is 1, or we can say 1 over 1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3 and so on up to 1 over 1 plus 2 plus 3 plus so on up to n. Here the last term is 1 over 1 plus 2 plus 3 plus so on up to n. And the denominator is the sum of first n natural numbers. We know that it is n times n plus 1 over 2. So we can also write it as 2 over n times n plus 1. This is the nth term. And we know that in order to find the sum, we need to take the summation of this. But we'll not be able to take the summation of the right-hand side directly. What we can do is we can split the denominator in such a way that we have two different terms. So for that, what we can do is we can write Tn as 2 common 1 over n times n plus 1. That is 2 times n plus 1 minus n. So I am adding n and subtracting n from the numerator. And now we can split the terms like n plus 1 over n times n plus 1 minus n over n times n plus 1. Here we can cancel out n plus 1 in the first part, and in the second part we can cancel n. So now we have the nth term. Tn is 2 times 1 over n minus 1 over n plus 1. By substituting for n equals 1, 2, 3, and so on, we get T1 2 times 1 over 1 minus 1 over 2. If we use n equals 2, we get T2 is equal to 2 times 1 over 2 minus 1 over 3. Similarly, T3 is 2 times 1 over 3 minus 1 over 4, and so on. If we add all these terms, and the last term is Tn, which is 2 times 1 over n minus 1 over n plus 1. Here, if we observe, we see that all the terms starting with 1 over 2, 1 over 3, 1 over 4, and so on, all the terms will cancel out except 1 over 1 and negative 1 over n plus 1. So sum of all the terms T1, T2, and so on up to Tn is equal to 2 times 1 over 1 minus 1 over n plus 1. If we simplify this, we get 2n over n plus 1, and that is the sum of all the terms. Let's look at another example where we can use the cancellation method. We need to find the sum of the series 1 over 1 times 3 plus 1 over 3 times 5 plus 1 over 5 times 7 and so on. Here, the odd term of this sequence will be 1 over, we have odd numbers here, 1, 3, 5. So it will be 2r minus 1. And this odd number is 2 more than this. So it will be in the form of 2r plus 1. We can easily simplify this by if I substitute r as 1 here. So it will be t1. It will be 2 minus 1, 1, and 2 plus 1, 3. Similarly, if I use r equals 2, it will be 4 minus 1, 3, and 4 plus 1, 5, right? But if we take summation here, we'll not be able to get the sum of the series easily. What we can do is, in order to use the cancellation method, we need to manipulate the numerator first. So in order to manipulate the numerator, I can write it as multiply by 2 and divide by 2. And the 2 in the numerator can be written as 1 plus 1. So we multiply it by 2, divide it by 2, and keep the other two terms same as it is. Now, in the numerator, we can add and subtract 2r. So 2r plus 1. And I'm subtracting 2r, so it will be negative 2r. And then you have the plus 1 over 2r minus 1 times 2r plus 1. And from the last two terms, if you take negative sign common, it will be in the form of 2r minus 1. And then we can split the terms. So if we split the terms, we'll get 2r plus 1 over 2r minus 1 times 2r plus 1 minus 2r minus 1 over 2r minus 1 times 2r plus 1. Here we can cancel 2r minus 1. Here we can cancel 2r plus 1. So we're left with 1 over 2, 1 over 2r minus 1 minus 1 over 2r plus 1. So that is tr. We have tr, we can find t1, t2, t3, t4, and so on, all the terms, and then we can add all of them vertically. So if I use r as 1, we'll get 1 over 2, 1 over 2 times 1 minus 1 minus 1 over 2 times 1 plus 1, which is same as 1 over 2 times 1 over 1 minus 1 over 3. And if we find t2, that will be 1 over 2. Again, now we'll substitute 2 here and 2 here. So we'll have 1 over 3 minus 1 over 5. And then t3 will be equal to half times 1 over 5 minus 1 over 7, and so on. Similarly, tn will be equal to 1 over 2, 1 over 2n minus 1 minus 1 over 2n plus 1. Here we can see that we can cancel out negative 1 over 3, positive 1 over 3, negative 1 over 5, positive 1 over 5 when we add all the terms. Similarly, 1 over 7 will cancel out. And same way, this 1 over 2n minus 1 will also cancel out. So we'll be left with just 1 over 2 times 1 minus 1 over 2n plus 1. So sum of t1, t2, t3, and so on up to tn is equal to 1 over 2 times 1 minus 1 over 2n plus 1. So this is the sum of the series, that is s is equal to 1 over 2, and we can take LCM here, so 2n plus 1 minus 1, so it's just 2n over 2n plus 1. We can cancel 2, so we have n over 2n plus 1, and that is the sum of the given series. Find the sum r from 1 to n, 1 over r times r plus 1 times r plus 2 times r plus 3. We have the rth term as 1 over r times r plus 1 times r plus 2 times r plus 3. We'll not be able to take the summation of the denominator here directly, so we need to manipulate the numerator and then split the terms by using partial fractions or by some kind of manipulation of the numerator. In order to manipulate the numerator, we can multiply and divide by 3. So it will be 1 by 3. And in the numerator, we are multiplying by 3 over r times r plus 1 times r plus 2 times r plus 3. And we can also add and subtract r to it. So doing this, we can take r plus 3 as one term and r as the second term, and then we can split the terms. So it will be 1 over 3 times r plus 3 over r times r plus 1 times r plus 2 times r plus 3 minus r over r, r plus 1, r plus 2, and r plus 3. So here I can cancel r plus 3, I can cancel r. So we are left with 1 over 3 times 1 over r, r plus 1, r plus 2 minus 1 over r plus 1 times r plus 2 times r plus 3. Now we have TR. So what we can do is substitute R equals 1, 2, 3, and so on. R equals 1. We get 1 over 3 times 1 over R, which is 1, R plus 1, so 2, R plus 2, that means 3. So 1 times 2 times 3 minus 1 over R plus 1, R plus 2, R plus 3, that means 2, 3, 4. Similarly, T2 will be equal to 1 over 3 times 1 over 2, 3, 4. And this will be 3, 4, 5. Same way, T3 will be 1 over 3. And that's 3 times 4 times 5 minus 1 over 4 times 5 times 6 and so on. Same way, we'll find Tn, that will be 1 over 3 times 1 over n plus 1 and n plus 2 minus 1 over n plus 1, n plus 2, n plus 3. So we see that all the terms will cancel out except 1 over n plus 1, n plus 2, n plus 3, and 1 over 1 times 2 times 3. So sum of all the terms T1, T2, T3, and so on, the sum is, we get 1 over 3 times 1 over 1 times 2 times 3, which is 6. So 1 over 6 minus 1 over n plus 1 times n plus 2 times n plus 3. And that is the sum of n terms of the given series. If you are asked to find the sum of infinite terms, so we say n tends to infinity. If n tends to infinity, we know that 1 over n will tend to 0. That means 1 over n plus 1 times n plus 2 times n plus 3, that will tend to 0. That means the second part here, that will be 0. So sum of infinite number of terms of the given series will be 1 by 3 times 1 over 6 or 1 over 18. Harmonic progression or H.P. A sequence A1, A2, A3, and so on up to AN is known as harmonic progression if 1 over A1, 1 over A2, and so on, 1 over AN forms an AP. In other words, we can say that if you take reciprocal of an AP, you get HP. So if 2, 4, 6, 8, and so on, if this is an AP, then 1 over 2, 1 over 4, 1 over 6, and so on, this will form an HP. So if three terms A, B, and C are in HP, then we know that 1 over A, 1 over B, 1 over C will be in AP. And we know that 2 over B will be equal to 1 over A plus 1 over C for any three terms in AP. This is the relation. If you simplify this, we get 2 over B is equal to A plus C over AC, or B is equal to 2AC over A plus C. So this is the relation between terms A, B, and C when they are in HP. The nth term of an HP is the reciprocal of corresponding AP. So it is 1 over AN. So here it will be 1 over A1 plus n minus 1 times D, where D is the common difference of the corresponding AP, and 1 over A1 is the first term of corresponding AP. And so this is the formula for nth term of an HP. If first three terms of the sequence 1 over 16, comma a, comma b, comma 1 over 6 are in GP and the last three terms are in HP, and find the values of a and b. So we are given with that the first three terms, so 1 over 16, a and b, they are in GP. So from here we get a relation that a square should be equal to 1 over 16 times b. So that's one equation. Second, we are given with the last three terms are in HP. That means A, B, and 1 over 6, they are in HP. And we know that if there are three numbers, they are in HP, then the relation between them is that the middle number is equal to the first term times the last term. So 2 times A times 1 over 6 divided by the sum of first and third terms. So A plus 1 over 6. If we simplify this, we get B is equal to 2a over 6 divided by 6a plus 1 over 6. We can cancel out 6. That means we have b equals 2a over 6a plus 1. So this is one relation that we have for b. And the second relation that we got was 16a square is equal to b. Now, if we compare these two, we get 16a square is equal to 2a over 6a plus 1. We can cancel out 2 and 16, so it will be 8. And we can cancel out 1a. So we have 8a is equal to 1 over 6a plus 1, which is same as 48a square plus 8a minus 1 equals 0, which can be factorized as 4a plus 1 times 12a minus 1 equals 0, from which we get two values of a as a is equal to negative 1 over 4 and 1 over 12. Now we have the values of a, we can find the values of b. b is equal to 16a squared. So when a is negative 1 over 4, in that case, b will be equal to 16 times negative 1 over 4 square. So that is 16 times 1 over 16, so 1. And when a is equal to 1 over 12, b will be equal to 16 times 1 over 12 square. And that's 16 times 1 over 144, that is 1 over 9. So finally, harmonic mean or HM. If there are three terms A, H, and C, and they are in HP, we know that the reciprocals of these will be in AP. So 1 over A, 1 over H, and 1 over C will be in AP. And for any AP, we know that the common difference is same. So 1 over H minus 1 over A is equal to 1 over C minus 1 over H, which gives us 2 over H is equal to 1 over A plus 1 over C, or H is equal to 2AC over A plus C. Here, this value of H is called the HM between two numbers A and C.